on YouTube to start talking.
Yep. Oh, that makes sense. Maybe this works
And
better.
we are live on YouTube with a few people already connected. The usual one, like Maddie, we spent part of the afternoon together trying to debug something. Hello, Maddie. Joseph is there. Anza. Jalil is there as well. I think you were the first one even connected on the Slack. Glenn, hello. Thank you for joining us. Like usual, we love to know where you are. So I am in Lille. It's a small city north of France. If you can drop your location in the chat, I'm going to read them aloud and to give us a sense of where you are attending. I'm not going to the meat of the content directly to leave enough time to everybody to join us on the stream. There are almost 1,000 people that will receive a notification that the stream is live. So on the ice in UK. Yes, there is something brewing up or happening in UK next week. Joseph is in Seattle. Glenn, you're in Nairobi, Kenya. Franck Lefebvre from Paris. Maddie from Tehran. Torsten from Switzerland. Um, yeah, it's always nice to see how international is this audience. As usual, my partner in crime is Janice for this meetup. Thank you for being here, Janice. You're
Hey,
in the Netherlands, if I
I
remember,
sure am.
unless you are still on holiday somewhere.
No, I'm back.
Back.
Unfortunately, I have to work as well on really exciting open source projects every single day. Not sorry about that at all.
In Denmark, we have Mats Odgaard, that will be our first speaker tonight. Mats worked with Conrad from the Swift team on exciting Java interoperability, Java and Swift interoperability. You're going to talk about that in a minute. And somewhere in Czech Republic, Wojciech, from Cultured Code. Maybe the people don't know the name of that company, but they know an app that you are doing. It's the how would I define that app in one word? It's an organizer. If I say a to-do app, it's probably way too restrictive. You will define it way better than me. It's the Things app that you probably have on your phone, and you're going to talk about the backend infrastructure and how Swift plays a role in that. Mats, looks like you have some friends from Denmark as well. We have Jotech 2009 from Denmark. We have Jacob from Aarhus in Denmark. We have Steven from Belgium, Ghent, or close to Ghent. So that's the content for tonight. As usual, let's try to make it interactive. Ask your question on the chat. If I can, I will put the question live on the screen. Otherwise, I will just read them aloud, and our guests, our speakers tonight will answer your question. I mentioned something that is brewing up in London. It's actually next week. It's the new edition, the 25 edition of the server-side Swift conference organized by Tim and his team. This year, the conference will be over 3 days. The first day will be workshops. So you come with your laptop and you will have a hands-on exercise to do all day long. There are three
If you're
different workshops. Yes,
if you're
Janice?
new to server-side Swift, there is a really cool track to get started with server-side Swift as well. The other track is also exciting about embedded Swift and I think concurrency.
Correct. So the first track, the fundamental workshop, it's a 1 day workshop starting from the morning until the end of the day. It's run by Apple, and it really takes you step by step how to create a REST API with OpenAPI and deploy that on the server. At the end of the day, you're going to deploy that to the cloud. Wow, that's exciting.
Something
And
you can really use with your app.
And the other track is more advanced. It's about concurrency and isolation with Matt Massicot, and Frank will show you how to develop for the embedded world. And then we have the usual conference over 2 days with a keynote from Apple, day one in the morning, different talk about concurrency, about Valkey, about server-side web frameworks such as Vapor, Hummingbird. We are going to talk about gRPC on day two, um, observability, which is also an important subject, and many more. The lineup of speaker is so exciting. Mats, you have a talk there as well. You're going to talk about Swift and Java interoperability as well. And I'm looking forward the last talk of Friday as well about the new container infrastructure from Apple. The what do you think about the lineup, Janice? Because you've been part of the team that read
Yeah,
all the proposal and you had to
I sure
choose.
have. And I was completely blown away by the amazing set of talks and topics and speakers. Really excited to also be there again myself speaking, but it's a really tough competition, really tough. I think we had to drop some really exciting talks during the organization because there were so many more topics that I would have wanted to see, but unfortunately there are only 3 days, which I think is more than enough. But at the same time, with all the other topics, it was a bit unfortunate to have to drop some. It was that good. Um, yeah, you should. Anyone that can make it should really go there.
And you can still buy your ticket. You go to serverside.swift.info, serverside.swift.info. I will share the link on the Slack as soon as I stop talking. The other exciting news from last week or the week before is the release of Swift 6.2. Janice, you prepare a short recap of what we should know as a developer. What's new in Swift 6.2?
Yeah, let me take it from there. Let's see. You see it? Oh, great.
Almost. No, now we see just your.
It crashed or something. There we go.
It's there.
Yeah, so Swift 6.2. For some, it's been a really exciting release in some ways. For others, in other ways, I think the most common feature that many people have been looking forward to is approachable concurrency. So, for those unfamiliar, I mean, everyone's I'm assuming is familiar with concurrency these days, and also some of the warnings and errors that it emits. Well, for server-side use case, I think concurrency has been a brilliant release all throughout. Because on the server, you really don't want to be crashing your application. You want to have predictability over your code flow. And the structured and unstructured concurrency, in addition to the compile time race condition checking, just makes it so much easier to look at this code and fully understand and be confident in the concurrency around it, like race conditions and how you manage events in orderness. Async sequences are brilliant for iterating over database cursors and streams of bytes. So I think concurrency is great there. But on iOS, people seem to care more about quick iteration cycles and concurrency. I can understand that concurrency can be a bit of a pain point here and there. So what they did is they have a new opt-in feature where you can isolate a module, your iOS app, to the main actor. I don't really recommend it for the server that much because that means that all your routes that you run are on the same actor, on the main actor. But for some smaller apps, it could be really helpful or help you get started more quickly with your Swift code. There are some new non-isolated semantics. Non-isolated now runs on the caller executor, so it doesn't necessarily hop to the global concurrent executor. Bit more performant for server use cases, which I'm really happy by. Also gets rid of some verbosity that we had in some Swift versions around async iterators. And there is a new concurrent attribute that allows you to explicitly run code on the global concurrent executor, even if your entire module is really main actor isolated. So I think approachable concurrency just makes it easier for people to get started with Swift, which is better for everyone, of course. For high-scale backend applications, you might not want to opt into this. For small-scale backend applications, I think it's fine. What I'm more excited for is the inline array. So inline array is fixed size. You specify the amount of elements in the array up front, like 3. So if you have a vertex with 3 elements, X, Y, Z coordinates, you can now make it a double array or inline array of 3 doubles. These can be stored on the stack, meaning that it's a pure value type. It's copied around. It's not. It's it's not heap allocated. It's stack allocated. So Swift can really optimize that a lot. It's also really great for embedded Swift, where of course you care a lot more about this footprint and not allocating on the heap. I think embedded Swift is a really exciting topic in general, so I'm really happy to see that improving everywhere. My most favorite feature, span types. So those working with server-side Swift know byte buffer, of course, and those working with Swift more frequently know that you can make an array of bytes, uint8. You can also have a data type from Foundation. Data is more optimized for macOS and iOS, so we avoid it on the server. But really, sometimes, like if you have a JSON parser, like JSON decoder, you want to support data because it's a part of Foundation, and you use iOS. You want to support iOS apps, so you really want to support that Foundation data type. But at the same time, some people use array of uint8 on the server. Use byte buffer. On embedded, you might have an unsafe buffer pointer to byte. So the backing type can change on the different platforms, and you want to expose the same module across the board. So I think Span is a great library, a great component to the ecosystem. It's part of the standard library that allows you to get a view of any of these types. And for the duration that you have the Span, you can't access the backing type, so you don't have you don't have race conditions or conflicting access, simultaneous access. I think it's a great type. There's also mutable Span for writing data. Span itself was read only. And there is output span, which allows you to append elements to an array itself. It does have a maximum capacity, so it doesn't really realloc. I hope the new patterns will emerge that will help us with growing types. Swift testing got some good updates, I think. So we now have exit testing that allows you to test crashes, preconditions, fatal errors, all of that good stuff. These were situations that were previously not testable. And then there are test result attachments, like common examples of test result attachments would be an image, like a screenshot in your iOS app. But on the backend, we could maybe have a list of database records. GRDB there's GRDB diffing by point freco, I believe. That already seems to be playing into similar tools, where you can have a snapshot of your database and compare whether your operations do the same mutations. And these can be surfaced in test reports. So you can have an attachment in your XC test file as the XC test results to see what happened and why it went wrong. Developer tool-wise, macro build times are improved, which hopefully unblocks a lot of macros in the ecosystem. Maybe even in Swift distributed tracing. So you can have an add trace macro on your functions. What they did is they now have a precompiled version of the macro Swift syntax library, so that you don't compile it every time you build a module with macros. That's going to save you a lot of compile time. I saw that WebAssembly support was in the latest tool chain, so you can now build proper WebAssembly apps with Swift without having to download a snapshot. WebAssembly has been really, really evolving thanks to Max Asiato's efforts and the rest of Apple. I think getting Swift in the web browser could be really exciting. We're also Swift on WebAssembly clouds. Something I'm also keen for, the VS Code team seems to be expanding within Apple, and they added doc.c support. Better debugging support experience for async code. I think they now have proper stack trace, including going back into previous tasks in the hierarchy. And I had a typo here, but the subprocess library has a 010. Subprocess is kind of the new Foundation process, which is what you use to spawn like a Git command line utility. Really, really happy to see that there is a new library, new component for calling into these other CLI functions. And then out of my own stream, the Swift Android work group has made some huge progress. Mark and Finagolfin have been working on getting the CI set up for creating SDKs. I think we're really close to a first release on Swift.org, so we'll have Swift, an Android SDK for Swift very soon. And we're now working on discussing the next development tools that we want to evolve in the ecosystem. There's also a bi-weekly meeting. I just got out of one. So if you want to be involved in Swift on Android, definitely be in touch. And I think the ecosystem has just been evolving that much more, even outside of what I just discussed. Like it's surprising how much progress we've been able to fit within just a span of a couple of months. So really excited to see where the ecosystem takes from here, thanks to all of you.
I'm really curious to see what it means to develop for Android with Swift. Maybe that might be the subject of another meetup. Invite Mark and you to present.
Yeah, you definitely should.
Something on Android. Leave us your feedback on the forums, on the open source Slack channel, or here in the stream. If it is a subject that you are interested for, we will organize something around Android. Thank you, Janice, for the Swift 6.2 update. It's exciting. What about the interoperability with Java? Mats, you can share your screen and the stage is yours.
Thank you. Let me just share my screen here. Whoop. There we go. All right, cool. Well, thanks a lot for having me. I'm very excited to be here. I've been a bit involved in the server-side Swift community as well, especially around Vapor. Today's talk from me is maybe not that server-side Swift relevant, but at least it can perhaps be a way for you guys, Swift developers, to go back to your client developers and say, hey, now you have the chance to write Swift just like me, and we can share even more code across the different platforms such as server, iOS, Android, and more. All right, yeah, so this project that I did was a Google Summer of Code project. I worked with Conrad from the Swift team over the summer, and we worked together on expanding the current Swift Java interoperability that's available. So when we're talking Swift Java interoperability, we're talking in both directions. So that both means calling Swift from Java and calling Java from Swift. In this talk, I'm going to be primarily focused on calling Swift from Java, so the one direction, but both directions are actually possible. Now, you might ask, why should we even call Swift? Why should we even care about calling Swift from Java? Well, sometimes in Java, we want to write very performant code, very safe code, and that is where performance native languages like C, C++, and Swift are very critical. And Java has been implementing native methods using the JNI for decades. And we all know that Swift is the safer alternative to C and C++. And also we've got a huge range of already open sourced available Swift packages that are just ready to be consumed by the Java platform as well. So the library that makes all of this possible is the Swift Java library. It was released actually at last year's Server-Side Swift conference by the Swift team. Now the Swift Java library provides different tools for interoperability. It has different macros that you use to wrap Java classes for use in Swift. It has command line tools. And the one tool that we are very interested in, and the one I worked on over the summer, is the JExtract tool. Now the JExtract tool is a source generation tool, a command line tool, and also used as a build plugin. And what it does is that you're able to give it your Swift sources and it can automatically generate Java wrappers for you. So the way it works is that you give your Swift library to the JExtract tool, it will analyze the code, and it will automatically generate Java and Swift files that are needed in order to run your Swift code on Java. This can be bundled up into a jar or an Android package and be shared with your Java clients. Now, this tool uses the Java Foreign Functions and Memory API, or FFM. Now, this is an API that was recently added to the Java JDK, and it gives basically the developer a lot more control over the native memory. It's also a much safer alternative to the Java native interface that we've known for decades and it's been around since the beginning of Java. And it gives better performance and much better safety when interacting with native memory. Now, what's the catch? This all sounds very good, and it sounds like something that we as Swift developers love, safety and performance. So what's the problem with just using this? Well, if we take a look at the JEP for the language feature, we see that it was released in Java 22. Now that's a quite recent release, and unfortunately that means that no Android support. That's quite a bummer because Johannes and the rest of the Android working group is working so hard on making this Android SDK available and bringing Swift to Android. And we need more tools that will automatically take your existing Swift code and make it usable on platforms like Android. Well, luckily that is until today, because I'm happy to announce that we have achieved adding a new mode to the JExtract tool, namely the JNI mode. So if you pass the mode JNI to the JExtract tool, it will generate source code files that uses the JNI instead of the FFM. So if we compare these two modes that are available, we have the JNI mode, which supports Java 11+. That makes it compatible with Android. And where FFM is more meant for modern platforms that have very critical performance requirements, JNI will probably have worse performance. It will make more copies between the JVM and the native memory. But also, we actually accomplished a wider set of Swift language features that are available in the JNI mode compared to the current FFM mode. Now, this is some Java code, and it might look strange for us Swift developers, but it looks like I have some person class, I'm setting a mood, I'm switching over what looks like an enum, I'm calling a closure, a lambda function. I also have this generic function in the end, and this is all Java code, right? Well, what if I told you that all of the code I'm highlighting now is actually Swift? All of these classes, functions, enum types, generic parameters, protocols are all automatically wrapped from Swift using the JExtract tool. Now we've gotten a bunch of cool features already supported. So we have all the basic features, for example, initializing classes, structs, calling functions, setting variables, getting variables. But we also got a bunch of cool features that the FFM mode does not have yet. So this includes like throwing functions, generic parameters, protocols, extensions, opaque types, and even more. Now, of course, the goal is for the FFM mode and the JNI mode to have feature parity. So if you're interested in collaborating with us, it would be a great way to get started and bringing some of the features that we added to JNI back to FFM. Now, so all the basic stuff works, that's great. But let me take you into how we built one of the most advanced things that we built, namely how we introduced enums to Java. So let's consider this rather basic vehicle enum. It can either be a bicycle or it can be a car. Now the car can have an associated value, which is a maker of a string, and it also has some initializers, variables, and functions. Now, how would we use this vehicle type after we've wrapped it? Well, it looks a lot like Swift. We can switch over the cases of the vehicle, and depending on if it's a bike or a car, we can make different decisions, and we can automatically extract the associated values from the Swift enum in Java. Now, this is thanks to new features in Java like pattern matching and the fact that we're using sealed interfaces and records under the hood. But this is a very nice API for Java developers and Swift developers to use. Now, if you take a look at the code that the JExtract tool actually generates, it's a bunch of Java code, right? It's all of this code that you see rolling on the screen right now that it generates for this rather simple enum. And that's not including all the Swift code it needs to generate as well for it to actually do the interoperability. In fact, it's 368 lines of code. And that's a bunch of code for just like 8 lines of API, right? And this code is very tricky to get right because messing with the JNI is a cause of many bugs. So it's actually 368 lines of code that you don't have to write because we did it for you. And on top of that, we've made several performance improvements that make sure that it works very well. Okay, let's take a step back. So this is the vehicle class that is automatically generated by the tool. I've condensed the functions and only kept the public types. We see here that we're using the sealed interface Java type and records in order to represent the different cases that an enum can have. This is what gives us the exhaustive switching over all the records that implement the case interface. Combined with the getCase function, this is what allowed the switch syntax that we saw previously. Now we need a way for Swift to tell Java what the case of the enum is under the hood, right? And that is where we use a discriminator. So a discriminator is a Java type. For each enum that it wraps, it has all the cases listed. So we somehow need Swift to tell us which case are you in. And this is where we have the getDiscriminator function. And here we're using the .values function on the discriminator. This is very reminiscent of the case iterable type that you know from Swift. Now, it looks like we're indexing into this array of values using the return value of a function called $getDiscriminator. And we're passing in some weird memory address. What is all this about? Well, this is actually where all the magic happens between Java and Swift. This is the native functions defined in Java that can be implemented by native languages such as C or C++ or Swift. So we define the $getDiscriminator as a native function, and it allows us to implement this in Swift. And here we see that we're passing in a long, which is called self, and the value that we're passing is this memory address. Now, in order to understand this a bit, we need to take a look at how we interact between memory, between Java and Swift. So let's take a look at this rather simple example. We have a vehicle where we're using the car case initializer that is defined on the vehicle. We're passing in an associated value of BMW, and we're returning that into the vehicle variable. So the way this works under the hood is that the car function makes a native call down to Swift, passing in the associated value. This tells Swift to allocate on the heap case and the vehicle case and set the case to car and put in the associated value BMW. Now this lives in the Swift memory space. What is actually passed back to Java then is that Java initializes a wrapper object, which lives in the JVM. This wrapper object basically just contains a pointer to the memory address in Swift where this vehicle instance is actually. And this is what is accessible through the memory address function. So that is what we're passing through these functions when we see self. So how do we actually implement such a native function in Swift? Well, first we need some way to tell the JVM how to find the function that it's looking for. This is where we're using the _cdecal attribute in Swift and giving it a very specific name that it knows to look for depending on the function signature in Java. Here we're passed in, as we can see, the self pointer, and we're expected to return an integer or a JInt. And we also see that the long has been converted to a JLong. These are the specific JNI types, so these are actually C types that the JNI knows about. So we need some way to convert a JLong into an integer in Swift that we can actually use, right? Now this is where the Swift Java library already had a bunch of great tools for interacting with the JNI. For example, the initializer from JNI. This takes the JLong and converts it into an int64, which is a Swift type that we know and can work with. Once we've extracted the pointer or the memory address, we can use the unsafe mutable pointer initializer to get an actual pointer to the vehicle stored at that instance or at that memory. This is what allows us to access the underlying memory, switch over the case that we're in, and depending on if we're a bicycle or a car, return the correct index into the discriminator values that we saw previously. All right, so in the getCase function that we talked about previously, we call the getDiscriminator to get what case are we in. Depending on that, we then either want to return the associated values of a car or of a bicycle. So this is the getAsCar function. It returns the underlying associated values back to the developer. So how does this work? Well, the getAsCar function returns an optional, because even though in this case, we've just made sure that the actual instance on the Swift side is a car, any developer could call this function at any time, and the case might not be a car, it could be a bicycle, and therefore it should return a null or an optional. So the getAsCar function makes a native call to Swift, where it takes in the pointer to the vehicle and it returns a J object. Now a J object is basically a wrapper for an object in the JVM. And the reason that we're doing this is what we're passing back from Swift to Java is actually a box of the associated values. But the box is actually a Java type. It's a record containing all the associated values that we need. So what we will do is that we replace this J object by native parameters for better readability. Now what will happen in the function is that we'll go down to Swift, extract this instance that we know, and then we can extract the car values and extract the BMW associated value. Now what we will do is use the JNI functions that allows us to initialize Java types from native land and give in parameters. So we're going to create a new instance of the Java type native parameters passing in the BMW. And this is what we will actually pass back from Swift to Java containing the native parameters. And this is what Java can then unwrap and at end return the correct case that it wants. This is how that function looks like when it's generated. It's it reminds a lot of what we saw before. The important parts are here. This is where we're using the JNI methods find class and get method ID, a new object, in order to find the correct class that we want to instantiate, find the correct initializer, and then actually allocating an object on the JVM. Now, these functions can be quite slow because they have to interact with the class loader to find the correct class, and it has to locate the correct method ID, and that is quite expensive. And we're doing this each time. But luckily, we implemented a caching mechanism for this. So we're actually caching the class reference and we're caching the method IDs for better performance. Now this is something that you would have to remember to do yourself if you were wrapping the classes by yourself, but the JExtract tool handles all of this for you. And it's actually 35% faster with the caching, so it's quite great. All right. That was a bunch of details, a bunch of stuff. And what I hope came across is that this tool generates a bunch of code that's very hard to get right. As I said, the JNI is known for, if you don't implement it properly, it can cause a bunch of bugs that's very hard to debug. Also, we have the ability to generate very performant and safe code since we're source generating it. And the most important part about this JNI mode is that it has multi-platform support, and especially for Android, working with the Android SDK so that we can automatically take our existing Swift libraries, wrap them for Android use, and be able to share code across many platforms. Now, I wanted to show a quick demo of using this tool in order to wrap the library for Java.
Yeah, we love demo.
Now, let me know if the screen sharing still works. It does.
Yeah, it does. If you can maybe just increase the size of your font a bit for older people like me. Yeah.
Oh, is it good?
Yeah, thank you.
Cool. All right. So let me take you through this example. So what I have here is I have a Swift package. It's called hashing_lib, and it's basically going to hash some strings I give it. Now this is the package.swift file that you all know. It has a bunch of code here that's pretty much only used to find where Java is installed on my machine. And then down here we have the actual package definition. So here we see that we're defining a library called Swift hashing. It's of type dynamic. This is what allows us to actually generate a file that we can put inside Android library. And down here we have put a dependency on the Swift crypto library. So this is what we will use under the hood to do the actual hashing. Now we've also added the JExtract Swift plugin to our target so that it would automatically wrap all of our Swift files when we build. So what does the code actually look like? So it's pretty simple. It's just one public global function called hash, taking in some input and returning some. We're taking in a string of input and returning a string. And here we're using the SHA-256 hashing function from the crypto library. Now I also have this Swift Java config file. This is what the JExtract tool will read to configure the JExtract tool. So it has different options. One of the most important ones is that I have enabled the JNI mode, and I'm specifying what the Java package that I'm outputting should be named. All right, so that's it for the Swift package. Now we need a way to build this Swift package to Android. So I have got another window over here in VS Code, just for better readability. And here I have a bunch of Gradle files. So I basically set this up as a Gradle project, and I've included the Android plugin and a bunch of stuff in order to generate this. Now, the most important part that we want to look at is this JExtract custom task. What it basically does is that it looks at all the files and it runs the Swift build command, but passing in the SDK or the Android SDK in order to build this for the Android. And there's a bunch of other stuff going on, like copying the runtime files and stuff like that. But that is basically the gist of it, and putting files in the right places and so on. Now, the final thing I want to show is that I have an Android project open. Here I have got an Android application running. It's a pretty simple app. I write in some text, and it's supposed to hash my text. Oh, that doesn't look right, right? We haven't actually implemented it yet. So let's build our library for use. We'll go back into VS Code, open up a terminal. And what we basically have to do is run the assemble release command in order to build an Android package that can be used in our project. So I will run this command, and it will be building. There we go, it was successful, that's great. So if we take a look at the build folder over here in our project, we can go into outputs and AAR, and we actually see that we have our hashing lib release AAR available for us here, okay? So let's try and put this in our Android project. So I right click on the file, I want to copy the path, and then I go back into my Android project. I go to File, and I want to install this dependency. So I basically press the plus, jar, and AAR dependency. I paste in the link to the file, press OK, apply, and OK. All right, that seemed to go pretty well. Now let's try and use this. So since this was a global function, the JExtract tool wraps all global functions in a namespace that is equal to the name of the Swift library. So I should be able to write Swift hashing here, and it actually shows up. And I have access to the hashing function. So I can pass in the value of my text field and set that. Okay, let's try and run this. Okay, our Android application is running again. Let's try again. And it works. So it's hashing our input using the Swift crypto library under the hood, returning the value back to Android, and we haven't even written a single wrapping file ourselves. The JExtract tool handles all of that for us. So that was just a quick demo to show how this thing works. I have a few more slides before I'm done. So what's next? So we've done a bunch of cool stuff, and we still want to do more. We've got great ideas for what to do next. We really want to tackle the proper way to distribute and package these Swift libraries into, for example, Android or jars, the proper way to do that. And we also want to look at how we're going to handle transitive dependencies, because it's very normal for a Swift API to include types of its dependencies in the signatures. So how do we support that? How do we automatically wrap the dependencies as well? We also really want to do Java implementations of protocols. So imagine that you could have a protocol in Swift, and then your Java developer could write the implementation in Java and pass that to your Swift functions. And of course, there's the whole story about Swift concurrency. So if you're interested in Android, Java, the interoperability story, or anything, you should definitely come and help us build this tool so that we can get Swift on even more platforms. I've put a link to the repo here, and I'll definitely be, I'll more than gladly help anyone out get started, and Conrad will as well, I'm sure. Yeah, so that was all I had. So yeah, thanks a lot.
That was excellent. Thank you for the talk.
Cool.
Yeah, thank you, Matt, for this presentation and this demo. I'm quite impressed by the bidirectional capabilities. So the obvious use case is Android, because most of the Android applications are written in Java and Kotlin. how can we apply this to a server side, like for backend migration, for example, progressively replace Java code or introduce new capabilities with Swift around existing Java monolith?
Mm-hmm. Yeah, so I think, of course, the JNI mode was motivated by the need to support older platforms. I think most server-side platforms can probably update their Java versions and recent releases, but there still might be some older server platforms running that need to maybe call that can use Swift libraries, and there the JNI mode is a great example for that. But there's also, of course, always the FFM mode. And the FFM mode is really meant to be able to be used on modern platforms like servers, so that you can use your Swift code in a very performant and safe way in your server-side Java applications, for example. So that would, but also as I mentioned, I think it's a great way to share code on the server, the Android application, the iOS application, because you can have one library that is used on all three platforms now. And you can just use this plugin to automatically generate the wrappers that you need in order to run it on Android. So you could imagine having like a crypto library that is used across all three platforms. So you can have a specific network implementation or stuff like that that can be written on all three platforms in one single
shared business logic, even like a state machine,
exactly.
right?
Yeah.
So
a bunch of use cases.
Or simply a common data structure to share between applications.
Yeah, exactly.
There is a lot of impressive, excited applause in the chat, but there is no questions. So I propose to switch to the next talk.
No, I have one question.
Oh,
first.
sorry, Janice. Apologize.
I saw that. So I'm really impressed by the Gradle setup that you have there. Is this example project open source already?
No, but I can make it. But it's very it's hacked together.
That's fine.
As I said,
like we were talking about generating AAR from Swift today in the Android work group. So this might be a really interesting starting point.
Yeah, this is one of the interesting things that me and Conrad has been speaking a lot about. It. How do we actually, so we can generate the code, but how do we wrap it up in a nice way that can be easily used for everyone? So this is some of the work that we are looking forward to tackling also with the Android working group and stuff like that, getting an official SDK. So things are really looking exciting for the entire ecosystem coming up. So I think it's a great time to be a Swift developer, I think.
And Matt, you will be in London and at the conference next week. So if you are interested about Swift and Java interoperability, you can talk with Matt. I don't know if Conrad will be there next week as well.
He will. Yeah,
he will. So you will have all the person to talk with to see how we can contribute to this project. Gregorio is asking if it is production ready.
I mean, it is. It is in the way that it works. The stuff that we've got now works. There's still a missing step in like making it easy to use. So for example, the generated codes, the generated codes depend on a library that is written in Java, which has some functions that we need. And since this tool is under the Swift Lang work like the GitHub organization, there are some things about releasing a library and stuff like that need to be sorted out. But as you saw, it can be done by cloning the project yourself, building and stuff like that. So it is production ready in the way that you can use it, but it could be more user friendly to like get started. There's still some things that you have to do, and Android support is still like there's no official SDK yet, so there's a bunch of stuff but that's as Johannes said, that's something that's soon going to be ready. So I think it's definitely ready to be used right now, and we'd love to get feedback from people if they use it and what features would they need. And we're basically always thinking what is the most common API that Swift has and trying to make sure that we can wrap that.
Wojciech, Janice, other questions?
I'm just impressed, so I will stand also in the line of impressed people. And
Cool. Okay, we might have Tim that is joining us after your talk, Wojciech. Tim is one of the main organizer of the server-side conference next week, so you can ask questions about the conference, and he will probably browse the main theme for the conference as well as we did in the beginning. Wojciech, I'll let you share your screen, and the stage is yours.
yeah. Can you see me and hear me well? Because
We can see you, we can hear you well.
perfect. So I'm going to share my screen. So here we
And the
go.
screen is there. We can see your screen, and I put it full screen.
Perfect. Perfect. So, hello everyone. I'm Wojciech Rilko, a software engineer at Culture Code, and today I'm excited to share our real-world experience with using Swift on server in production. But first, let me introduce our company and what we do. We are Culture Code, a dedicated team of 11 people working fully remotely here at our nice Stuttgart office. And we make things. An award-winning personal task manager. Things has enjoyed great success with strong track record. The first beta version went public in 2007, and it was among the first 500 apps on the iPhone App Store. We've won the Apple Design Award twice, and today we have apps for all Apple platforms, which have recently all been updated with a major UI refresh and great new features for Apple's OS 26 releases. But it's not just our user interface what shines. Users equally appreciate our background sync service, Things Cloud, which launched in 2012 and has been greatly trusted by our users for its reliability. So, what does exactly Things Cloud do? Its main purpose is to sync user data seamlessly across multiple devices. And the most important aspect of this sync is resilience. It doesn't matter if user has flimsy internet connection or user is making changes on multiple devices while being offline. Once the devices are back online, they converge to the same state, so that user enjoys consistent data across all their devices. Such behavior is not easy to achieve. We had to develop rigorous framework inspired by theories of operational transformation and Git, the distributed version control system. Things Cloud also includes additional services, like handling push notifications and Mail to Things feature, which allows user to send an email to a special address, and it will automatically appear in their Things Xbox as a regular task. The backend architecture of Things Cloud, its code, patterns, and development process is the main focus of this talk. A year ago, at Server-Side Swift conference, hi Tim, I see the organizer is here, we gave a talk about how we transitioned our backend infrastructure from Google App Engine to AWS. And more importantly, how we've also switched from Python and C to Swift. I won't revisit the details of our previous system or the motivation for transition. If you are curious, I recommend you reading our guest blog post on swift.org. But what I'm going to revisit is our current architecture and reasons why we've chosen Swift, which are its compiled language with expressive type system, has automatic reference counting instead of less predictable garbage collection, and integrate easily with C and today even with C++. Finally, it's a language we are familiar with from client side. So today, I will start with a brief recap of our architecture, then dive deeper into how Swift shapes our code organization and patterns, and finally explore our development practices, including how we develop, test, and even intentionally break our system. So let's recap our architecture for context. Our Swift codebase has around 45,000 lines of code, and we build it using GitHub Actions. The final binary is around 75 megabytes, and clean build takes more than 10 minutes. I wish builds were faster. But we don't build and distribute the binary. We build Docker image with final image based on Swift Slim, having like 150 megabytes. And how do we run it? In Kubernetes cluster, together with some other supporting services. And of course, we use managed Kubernetes, EKS specifically. The home of our new platform is Amazon Web Services, AWS. And to interact with AWS from Swift, we use Soto library. To keep everything in order, we use Terraform as our infrastructure as code solution. This allows us to easily run multiple copies, or tiers, of our entire platform. That's super useful for development and testing. Our entire configuration is almost 13,000 lines of Terraform code. To run systems successfully, you have to know what's happening. We generate logs in Swift using custom JSON logger and ship them using FluentBit to CloudWatch, where we store them and search them, and it can also generate incidents. Incidents go to third-party service, PagerDuty, which wakes up responsible person. We also ship Prometheus metrics to CloudWatch. We generate them using Swift Prometheus package. Our Swift web framework is well-established Vapor, and Swift Neo serves as the underlying network framework and has proven to be a rock-solid foundation. So let's zoom in a little bit. Which database to use is a complex decision. We knew we wanted a relational database with proper transactional support and strong guarantees about durability of data. And we came to conclusion AWS Aurora MySQL fits us best. It has durable distributed storage layer, which we like. And in Swift, we are using Vapor's MySQL kit to connect to database. And it's worked very nice so far. The database struggled a little bit with schema changes of our table, which had over 1 billion rows and size of single-digit terabytes. So we had to develop framework how to offload the data to S3 while not losing transactional guarantees. And there's also need to store more ephemeral data, like push notifications or cached data. Redis is obvious choice there. We use Redis Stack Swift package, and although it's pretty basic, it works well. So far I haven't touched client's traffic. It's roughly 600 requests per second in peak hours, and it comes through AJ proxy, which processes it and forwards to a particular service. And once it arrives to our Swift service, it's up to Vapor to route it to our code. And then there is Mail-to-Think service, where arriving emails are passed around by SQS and are processed using Python in AWS Lambda. And finally, we talk to APNS, and we are working APNS Swift package for that. So that was a brief recap of our current architecture. And for this talk, we thought it would be great to show you 3 interesting Swift patterns that might inspire you. So first, let's discuss our approach to code organization and passing dependencies around. So we have one backend monorepo, which builds into a Docker image with one binary inside and some static assets. While we build just one executable binary, we run it in multiple ways with different configurations. Based on configuration, it behaves as completely different service. This allows for simple development with great code sharing, while enjoying operational benefits of running multiple different services. For example, only a particular service may need access to main database, and services can have different life cycles or memory requirements. As a disclaimer, we are not running some microservice architecture. We just have few different services. Our Swift code organization is simple. We have just one Swift package, so all the code is shared, and it's only about entry point configuration being slightly more complex. For code specific to a particular service, we just use name prefixes, as Swift doesn't have namespaces. So now let's talk about how we approach dependencies. As it's common, I'm also referring to them as services, but in the sense of the Swift components. So for example, APNS worker has database service, Redis service, and APNS configuration as its dependencies. Such dependencies are often globally configured and provided through some registry. Like here in our example, through Vapor application object. This is quite common, it's simple, and it works well. But in our case, we want better control over our roughly 60 dependencies. Moreover, remember, I mentioned we have just one Swift package with all our code, but we run it under different configurations. Based on configuration, only some dependencies or services are configured and thus available. Moreover, this gets more complicated because dependencies have relationships between themselves. We wanted to use static typing to track dependency requirements and availability in our code. So a global registry of all dependencies, like in the previous Vapor example, wouldn't be a great fit for us. Instead, we want something explicit, statically typed. But this quickly becomes far too verbose and painful to pass around. So we decided to use protocol composition to declare which dependencies we need. This makes passing dependencies around much more straightforward. It's just one parameter. So here's how our dependency system works in practice. At the startup, we determine which service to run based on the configuration. In this case, either an APNS worker or our main Things Cloud API. Then we load dependencies from environment variables and configuration files. The dependency struct conforms exactly to the protocols we need. The APNS worker, for example, needs configuration, database, Redis, and queue service, but nothing else. Then we can pass these dependencies to the APNS worker. Notice how APNS worker deps adapts multiple dependency protocols, but it seems like it only conforms to some of them. Like, how does it conform to database service dep, for example? It's just a bunch of configuration there. So it does so implicitly through default implementation in the database service dependency. This is a little bit tricky, but very neat. When a struct conforms to all dependencies that the database service requires, it can automatically construct the database service. This means it can also conform to database service dependency protocol without writing a single line of code. So this approach to dependencies gives us compile time safety with runtime flexibility with less boilerplate. Exactly what we need for our multi-service architecture. But Swift's type system doesn't just help us with dependencies. We also use it to be strict about our data validation and ensure type safety from controllers all the way down to database. Here is a practical example from our account creation endpoint showing our declarative approach. You can see our endpoint implementation. You can see our endpoint implementation must declare its dependencies, authentication methods, request body and response format, and finally the processing logic. We codified this structure into protocol because it's shared among all our endpoint implementations. So now let's focus on these rather unusual and specific types. Normally you'd see regular types here like string, integer, and so on. These would get validated and passed through the code to the database. But there's a problem. The code makes assumptions about these values, and the database has its own data types and limits and could reject the data. That's why we use types for specific constraint values, like email address or ASCII string under 255 bytes. These granular types make our function signature clearer and let us validate data right at the input where it's convenient. Once values are in the system, you don't need to check constraints again. The type system guarantees they are valid, and we know the database will accept them. And with integer generic parameters in Swift 6.2, implementing these types should become much simpler. But even with strict typing, we can still run into subtle bugs. Let me show you a specific pattern we use extensively. We call it tagged types. So look at this code. Both account and session use integer 64 for their row IDs. That sounds reasonable, right? They are just database row identifiers. But notice what happens in the delete account function. We load the account correctly using session.accountRowID. But then, ouch, we accidentally delete using session row ID instead of account row ID. Of course, this compiles perfectly fine because both are integer 64, but at runtime we delete the wrong record. That's a serious bug that could corrupt our data. You might think, well, let's just use type aliases to make this clearer. And here's how what it looks like. We define account row ID and session row ID as type aliases to integer 64. This makes our intent more explicit in the code. But notice what happens in the delete account function. We still have the same bug. The problem is type aliases are just names. They don't create new types. Swift still sees both as integer 64, so this compiles perfectly fine, but deletes the wrong record at runtime. So the solution are tagged types. We create a generic tagged row ID struct, which wraps the integer 64, but makes it type specific through the tag parameter, through the generic tag parameter. The tag is not used anywhere. It's just used to distinguish the types. Now, account row ID and session row ID are completely different types, even though they both wrap integer 64. With this change, the bug in our function becomes a compile time error. Swift won't allow us pass session row ID where an account row ID is expected. This pattern catches entire class of bugs before they reach production, and the runtime cost is 0 since the wrapper disappears during compilation. So type safety of Swift catches many bugs at compile time, but that's only half the battle. We also need robust and convenient testing practices. So good development process requires multiple copies of infrastructure. We run multiple deployments of our entire stack, a production environment, a staging environment for testing release candidates, and individual developer tiers where we experiment and develop. Setting all of this up is straightforward because we've invested in well-parameterized Terraform configuration. The only downside of this approach is the cost of fixed-price infrastructure components like EKS cluster. We want our development and testing environment to resemble production as closely as possible while remaining convenient for developers. Basically, we want developers to use Xcode locally as usual, while the debugged binary behaves like it would run in Kubernetes cluster. To create this illusion, we combine several techniques. So every developer has a full copy of entire infrastructure as their personal tier. This allows them to develop and test not only Swift code, but also Terraform configuration. Then we use Kubernetes port forwarding to access resources in the cluster like Redis. Some resources, like database, can only be accessed from within the cluster. For these, we connect through a deployed proxy. And finally, when running test or debug build, the configuration phase is adjusted, and instead of reading local files and local environment variables, we proxy these reads to the appropriate pod in Kubernetes. So we read exactly the same configuration as the deployed binary would read, including credentials. As a result, developers use regular convenient tools to develop and debug code, all while running tests with proper configuration, permissions, and against real components instead of mocks. Now, now let's talk chaos. So failures like your service crashing or network having issues or third-party service being down are unavoidable. For these cases, we have monitoring and various mitigation tactics like auto recovery and high availability. But how do you know these work? Especially if your backend is quite small for these failures to happen frequently enough. Chaos testing, where you intentionally introduce arbitrary failures to your backend, was immensely helpful for better understanding our infrastructure. To implement this, we use a set of scripts with elevated privileges and AWS fault injections service. Every day, we run scenarios like crash a Swift service, crash main database instance, terminate EC2 instance, disrupt traffic between availability zones, eat all the available memory, and so on. So far, we found multiple issues by running chaos testing, and we wholeheartedly recommend you to try it also. So, we want to end with the same conclusion as last year. Swift turned out to be a great choice for server usage. It delivered on everything we had hoped for. We are now using a modern and expressive programming language. The code runs and performs well. Compared to our previous legacy system, our new setup has led to a more than threefold reduction in compute cost, while response times have shortened dramatically. Of course, we don't have precise comparison with other modern alternatives, but we are definitely happy with the results. Swift ecosystem provides all the integrations we need, and we haven't encountered a single operational issue in 2 years of production use. So we encourage other teams to consider using Swift for server-oriented projects. While we chose to undergo a complete rewrite, the gradual adoption of Swift is also a tempting option, especially considering Swift's growing interoperability with C++ and Java. So, thanks for watching. I'll be at Server-Side Swift conference in London next week. Always an amazing event. So if you want to chat, feel free to reach out. And thanks.
Thank you, Wojciech, for this presentation and the impressive numbers that you shared as well. We have a couple of questions for you in the chat. One of them is about the data synchronization itself, like how to detect conflict. The exact question from Jalil is, how do you sync state across device? Is it self-written or something like CRDT, which is cross the device list?
Conflict-free replicated data types.
Exactly. Thank you.
That's a great question. Like that would be for another talk.
Another talk.
So just we don't use CRDTs. So I'll just give few random facts. We don't use CRDTs. We use some kind of like operational transformation, and we kind of detect conflicts using logical clocks, and we have like central log of the events which we are building on top, and there is clearly the log of the events is linear. So if you want to add something new, then you can detect if you are on top or somebody else added something new, and you can detect it. Then you need to do the merge conflict resolution and all of that. This is pretty complicated, but I think the core of the answer is that we have centralized place for histories. We have some centralized entity which is able to linearize the
All
histories,
the changes.
and then the CRDTs are not that much tempting for us because we can use the operational transform algorithm. So this is like for people who are curious about this, every year there's a great conference in Berlin which is focused exactly on this. People talking about how do they sync data in their apps. I can recommend it.
Mm-hmm. I'm taking the question in the order they appear in the chat. The next one was yours, Janice. I think it was very specific to one moment, very contextual. So can you repeat the context?
Correct. So you had these ASCII strings 255.
Yeah.
Are you going to be using the integer generics for that? So you can spell it ASCII string between generics 255.
Yeah, I definitely want to try that. Sounds cool. But I didn't try it yet. But I think it should work. Like from what I understood from the proposal, it should work, and I think this will simplify our code quite a lot.
Mm-hmm.
The next bunch of questions is about the end of your talk and chaos computing. I ask, what are the tools or the service or frameworks you are using to simulate failure? And second part of the question, do you do that on production or in a test environment?
That's a good one. So yeah, we have two production-like environments, the actual production and the internal production with restricted set of users. That's where we run this experiment because we don't really want to bother production users at all. So we bother some beta users or some internal users. So some people definitely notice if something is wrong or we overdo these experiments or something. And there is also actual monitoring on this tier. So when we run this experiment, we get the PagerDuty alerts, and we so it's like really production-like environment. And for the tooling, we use the Amazon fold injection service, which is pretty cool. It's able to simulate very interesting stuff. So we plan to expand what we break using this AWS service. And we also have some set of shell scripts which we run inside the cluster, and they do some mess. And for example, we do that in very simple, straightforward way. For example, if we want to crash the Swift service, the easiest way is to have private API where you unwrap nil, right? So you call this API and Swift crashes, or it allocates lots of memory in the loop and makes a pressure on the cluster. So this is very simple tools, I think.
And Jalil has a question about that as well. How much it can affect user experience? You answer that one. So it's your beta tester or the tester that knows.
It's even smaller group than beta tester.
Okay.
It's just like.
And he asks also if a service fails, how quickly it can recover. Does it recover by itself, or do you need operator? I guess it depends on the services.
Yeah. So the way how we have Kubernetes configured and other stuff, it's like it auto recovers immediately, basically. And because we run some high availability, you basically don't even notice. So we have multiple copies of the same service running. So if one of them crashes, you get a few requests in flight broken, but like the traffic still can go to other services, other copies, and that one is restarted immediately, and in a few seconds it runs again. So it's pretty cool.
Yeah, I guess for the user, it's just a matter of retrying, pushing again on the button or something like that.
Yeah, it's
and
just
it will
a
work. Mm-hmm.
temporary glitch. It's slightly worse when we, for example, break the network or the main database.
Or the database.
That's more interesting. Where these were actually also cases where we learned most about our infrastructure. Like we thought that we have high availability, and we found it's not that much available during some network disconnections. Like, for example, brain split between AZs. We found that we have some bottlenecks there, and we had to think about that. And we didn't realize that before running the experiment, before actually breaking the network. So it's super useful. And this stuff then like could lead to much longer downtimes. Like
that's the great thing about chaos engineering. It's not only to test your system, but also the human part of it. How do you react to errors? Talking about breaking things, and there is a question from Joseph in Seattle saying, do you include backtracing support within your image? So if so, what configuration for it? Is it symbolication, unwinding, or other techniques?
Yeah, I'm not able to answer that from memory. I don't remember details. Sorry.
But the answer is yes. There is some backtracing.
Yeah, I think so. I think so. Colleague was working on that. So somehow it's covered, but I don't remember details. I remember talking about this on server-side Swift conference in Parzone with the Apple engineer responsible for this feature. That's super cool about this conference, that when we have some tricky question, you can reach the person working on that.
And you mentioned a conference in Berlin. So Katwa is asking, what is that conference? Is the content available? We can share the URL on the chat.
I will paste the URL there.
Thank you.
I will paste the URL there. I think it's this Sync conference. It's pretty cool. And all the talks are recorded and are available on YouTube.
So that's a great occasion to learn from there as well. Talking about conference, we have a team joining in. Hello, team. We talked briefly about Swift server-side Swift conference next week in London. What's your pitch about it? You're the main organizer.
It's the only place
to be
where the whole industry gets together. So it's not like it's you have like go to an iOS conference and stuff, and you have like a few people from different conferences. Server-side Swift conferences where everyone from server-side Swift attends. So it's a really cool gathering of who's who of server-side Swift. Everyone involved from kind of the lower level stuff in Swift Neo and other Apple developed frameworks and Hummingbird and Vapor and kind of all of the other extra packages that are in the ecosystem. So it's kind of a very unique conference because it's pretty technical. So there's a lot of really interesting talks on server-side stuff because it's dedicated to that. And yeah, it's a really great place to network and meet people. One of the big benefits is the number of engineers from the community and from Apple who attend. So if you have problems, you can just go and poke them and pass to them.
And it's still possible to buy tickets. You go to
it's still possible to buy tickets.
Server-side Swift.
Off sale at the end of the week, I suspect. And the Experience Workshop is almost sold out. I think we've got like 1 or 2 slots left for that. Fundamentals, if you've never done any server-side Swift before, the Fundamentals is a great course to get started with that and teaches you how to do it. And that's super cheap as well. And then the main conference would be really fun. There is a discount code I can get
Oh.
out actually. If I just let me give you 1 sec to look it up. But if you use the discount code community15, that's community15, all uppercase. I don't know if I can put it in the chat somewhere.
Community.
We can put it on YouTube.
Yeah, if you put it on YouTube, it's community15 gives you 15% off if you still haven't bought your ticket. Yeah, the tickets probably close on Saturday, I suspect.
Excellent. And the 5 of us will be there. Wojciech, you will be there. Mats, you will be there. Tim, obviously. Janice, your speaker.
Yep.
I will be there as well. Thank you, Wojciech, for your talk. It's super inspiring to see what's possible, the realm of possible with server-side Swift as well. I don't see any other questions for you in the chat. There is a more general question, maybe for you, Tim, about Vapor 5. Any news about Vapor 5?
Yeah, because it's a very quiet time at the moment for me, so lots of time to work on it. But there has been quite a bit of activity on the repositories. So the Vapor 5 branch on Vapor is actually getting some work at the moment as well. We're currently implementing a new bidirectional streaming HTTP server.
Wow.
And there is a new routing kit release that's being worked on as well that's going to support partial path parameter matching, so you can support the full range of Open API spec stuff. So I could tag an alpha now, but I don't want to about to rip out the internals. So I'm going to wait until that's done before we tag an alpha. But the way that services work has been reworked, and that's implemented now for the most part. It's fully async awaits. It's using Swift concurrency through and through. So it should be good. I'm hoping once the conference is done, I can polish things off and get the alpha tagged, and then we'll spend as long as needed in alpha and beta making sure that it's solid before it gets released.
And maybe a meetup next year where you can present or demo the new feature.
Next meetup, we can have a little demo.
Excellent.
Cool.
Mats, Wojciech, any question for Tim, Janice, me? I hope we answer your question, Kiran, on the chat. Anyone wants to say something to close this meetup?
Well, if the speakers and the talks of server-side Swift are not enough to convince you yet, then definitely still be very interested in the people you'll be meeting there, because everyone in the server-side Swift community just gets excited meeting each other. And whether you're new to server-side Swift or an experienced developer, it's the place to be.
So I guess it will be the closing word for this meetup. Thank you everybody for attending, for everywhere in the world, different continents, just like usual. Tell about this meetup to your friends and your colleagues. All the meetings are staying online on YouTube, and you can watch them later on or rewatch them for some of you. Next meeting will be somewhere during Q4, I guess, if we keep the same rhythm. We have some ideas of talking about Android, talking about Vapor 5, maybe next year. We have a wish list as well. Janice and myself, we are going to communicate about that on Slack and on the Swift forum.
But if you have any ideas for
please feel free,
or topics that you want to have covered in the Swift ecosystem, then definitely send us a message wherever.
Thank you, Matt. Thank you, Wojciech. See you next week in London. See you next week in London as well. And enjoy the rest of your day or your evening. Bye-bye.